Hello friends, let's start with the topic interrupts in 8051 microcontroller. Myself Dr. Faiz Ahmed Kurne, Head Department of Electronic Science, Abeda Inamdar Senior College, Pune. We will see few definitions of interrupt. So we can say an interrupt is an external or an internal event that disturbs the microcontroller to inform it that device needs its service. Or we can say interrupt provides a method to postpone or to delay the current process and performs a subroutine task and then come back to the standard program again and then continue. The program which is associated with the interrupt is called interrupt service routine or simply called as interrupt handler. There is one more definition. We can say when an interrupt occurs, the controller completes the execution of current instruction and starts the execution of an ISR or interrupt handler. So this ISR is a piece of code that tells the processor or controller what to do when the interrupt occurs. So after the completion of this program, after the execution of ISR, the controller returns back to the main program from where it has jumped before the interrupt was received. Now let's see how it works. Step 1, upon receiving the interrupt signal, the controller completes its current task or can say current instruction and saves the content of program counter on stack. This program counter will store it stores the address of next instruction to be executed. So after receiving an interrupt, the content of PC will be saved in stack memory. Then the it will jump to a location, fixed location, depending upon the type of interrupt. So it starts executing the interrupt service routine program until it reads RETI instruction, that is return interrupt. So after executing this instruction RETI, the controller will return to the place where it was interrupted. There are five types of interrupts in 8051. The first one is reset interrupt, which is unavoidable. Second is timer interrupt. It has timer 0 overflow interrupt denoted as TF0 and timer 1 overflow interrupt denoted as TF1. It has external interrupts, that is INT0 and INT1. And the last one is serial communication interrupt, that is RI oblique TI. Hence it has got five interrupts. One is reset, TF0, TF1, INT0, INT1, RI and TI. Here it are there are six interrupts, but this is not counted in number of five. It is separate interrupt. We'll see each in detail. The first one is reset interrupt. This is also known as power on reset. So whenever the reset button is pressed, then it is giving the reset interrupt to the controller and the controller restart executing the program from 0000H location con- confirmly, so it cannot be avoided. Second is timer interrupt. So this 8051 has two timer interrupts, TF0 and TF1. It notifies the controller that corresponding timer has finished counting task. So TF0 is used for timer 0 and TF1 is used for timer 1. The next interrupt is external interrupt. These are two, EX0 and EX1, and they are denoted as INT0 and INT1. Serial interrupt, it is used for, of course, serial communication, and they are RI and TI. When enabled, it notifies the controller whether a byte has been received or transmitted. So this is used specifically for bit by bit communication. Now there is a register called as IE, interrupt enable register. Whenever the 8051 is reset, all the interrupts are disabled. That means none of them will be responded and they are not in active mode. So to activate them or to deactivate them as per our need, we use a register called as interrupt enable register IE. It is used to enable or disable individual interrupts. If the bit is set, then the corresponding interrupt is enabled, and if the bit is cleared or 0, then the corresponding interrupt is disabled. This is the format of IE register. It is 8 bit. The first bit is, that is 7th bit, is EA. It will enable any of the interrupts. So EA must be set to 1. If it is 0, no interrupt can be activated. So we must keep E1 equal to 1 to enable all the interrupts. Then this bit is reserved for the future use. ET2 is a timer to interrupt. It can be enabled or disabled. ES stands for serial interrupt. ET1, ET2, EX1, ET0 are for, ET1 is for timer 1, EX1 is for external interrupt 1, and EX0 is for external interrupt 0. So these can be enabled or disabled individually. So you can see here, if EA equal to 0, all interrupts are enabled. If it is 0, all are disabled. If ET2 bit is made 1, it will enable timer to interrupt, and if it is 0, it will disable the timer to interrupt. Same case with ES. If ES equal to 1, it will enable serial interrupt, and if it is 0, it will disable serial interrupt. Similarly, we have ET1, EX1, ET0 and EX0. So whenever these bits are set, that means they are equal to 1, the corresponding interrupt will be enabled, and if they are 0, then corresponding interrupts will be disabled. There is one more term that come under interrupt title, that is interrupt priority. So as I told in the beginning, 8051 has either 6 interrupt or 5. When we read RI and TI separately, then we have total 6 interrupts, and there is a possibility that more than one interrupts are activated simultaneously. So in that case, which interrupt should be serviced first? So 8051 has priority, you can see here. So if suppose these 5 are activated at the same time, then the first priority will be given to INT0, second to TF0, then int1, tf1, and then at the end ri and ti. So suppose these two are activated simultaneously, then int0 will be serviced first and then tf0. Same like if there is a call to you by principal, by your teacher, or by your friend, then you can decide to whom you should service first. That priority depends on the controller. So once again you can see the first is responded by 8051 called int0. Second priority is given to tf0. Third priority is given to int1, then tf1, and at the end ri and ti. So you can see here the arrow. So starts with the highest priority as int0 and lowest priority as ri and ti. So if any doubts, please feel free to ask on Gmail and send me mail on the mail address given below. Thank you very much.